Alright, so I'm looking at Module 4, Lesson 2 today. Today we're still going to be building tape diagrams to generalize some identities. Remember, this word generalize is a fancy word to mean figure out. So you do a couple examples and you say, I've figured out, I've generalized this identity. Yesterday we talked about addition and subtraction. We said, okay, well if you have 2 plus 4 minus 4, the identity told us, well, you just get what you started with. And then we even took it so far as to say with variables. So we said like x take away m. And then if you want to get back to x, what do you have to do right here? You have to add m. So today we're going to look at it with multiplication and division identities. We're going to try to figure this out. So let's take our first one. Go ahead and flip over to the daily lesson. Get my camera fixed up here. Let's flip over the daily lesson. It says draw just some basic stuff here to draw some tape diagrams to represent the following. Let's see, what do we call these things? No equal signs, just math phrases. The following expressions. These are expressions. So let's start this first. 8 divided by 2. Okay, well let's show this side by side. Well, let's start with 8. And 1, 2, 3, 4, 5, 6, 7 lines to make 8 of them. And says take your 8, and do what with it? Divide it by 2. So 8 divided by 2, what do? Make 2 groups. 1, 2, 3, 4. There's one group. 1, 2, 3, 4. There's another group. So when I do 8 divided by 2, I end up with one of these things. 8 divided by 2. So here's 8. Here's 8 divided by 2. Obviously, that's equal to 4. So 8 divided by 2, definitely 4. Nice. Well, let's look at another one. Try to draw this one on your own before we do it. If not, I'm going to go ahead here. So it says take 3, multiply by 2. So here's 3. 1, 2, 3. And let's see. So take 3, multiply by 2. 3, 2 times. And I'm going to run out of room here. It needs to be the same size. 3 times 2. So here's 3, 2 times. So we had 3, multiply it by 2. So 3 times 2, 2 groups of 3, right? That's what that means, 3 groups of 2. We obviously end up with 3 groups of 2 would be 3 and 6. Ooh, I better scroll down there on my page. 1, 2, 3, 4, 5 lines, total of 6. So obviously we had 3, multiplied by 2, got 6. Had 8, divided by 2, got 4. Just some basic stuff to set us up for those identities today. So the identity we're going to be generalizing, remember, what does it mean? Figure out, fancy word for figure out or discover. What happens if we multiply and then divide a quantity, I should say by the same quantity? So we're going to multiply and then divide by the same quantity. So let's use 3s and 2s. Those are usually easy to draw, easy to illustrate. So let's start with 3. Let's start with 3. So here's my 3. It says we're going to first multiply it, then we're going to divide it by the same quantity. Quantity meaning amount. So we're going to multiply this, and then we're going to divide it by the same quantity. So let's multiply it first. Let's do 3 times 2. Now you know what that's going to equal. Let's draw it though. 3, multiply it 2 times. So that means I need 2 of them. So here we go. This would represent 3. This would represent 3 times 2. So we multiplied, but it wants us to multiply and then divide by the same thing. So if we multiplied by 2, now we got to divide by 2. So I'm going to do 3 times 2 divided by 2. So let's take this thing we had. We had 3 times 2 already. We've already had this chunk right here. This is what we had. We had 3 times 2. Now let's divide it by 2. So I need to split it into 2 groups, essentially what that means. So there's one, there's another. So this thing right here, one of these is worth whatever 3 times 2 divided by 2 is. And what is it? Obviously it's worth 3. So that means I can say, I can basically write an equation at the end of this. I can say 3 times 2 divided by 2. Like if you double something and then you divide it by the same number, which would be 2, you end up right back at 3, right back where you started. Right back where you started. So let's see if we can maybe show this when we don't know the quantities. So we don't know all the quantities. We're going to know one of them, but we're not going to know all of them. So let's see what we think here. So let's try when we don't know the quantities. So again, we're going to multiply. We're going to multiply, then divide by the same quantity, and that'll help us figure out our identity. Let's think here. Well, let's start with, how about x? So again, when I'm working with a variable, I don't know how many lines to draw. So I can just basically draw my tape diagram like this. I can just say, oh, this is x. That's what it's worth. So first we're going to multiply, then we're going to divide. Same number, though. So that means we might take something like this. X times, let's draw a little bit bigger picture this time. Let's do x times 3. So that's the multiplying. But we're going to divide by the exact same thing. So let's see, x times 3, then we're going to do x times 3 divided by 3. And so what do you think we're going to get at the end? X times 3 divided by 3. What do you think that's going to equal? Let's discover and see what happens. So we're going to take x, and I'm going to multiply it by 3. So I don't just have one x. Don't just have two x's. I have 3 x's, not ex-girlfriends. That's obviously not a good situation. So here, x times 3. Now take x times 3, divide it by 3. So here's x times 3. Here's my picture. And I need to divide it into 3 groups. Here's one group, here's 2 groups, here's 3 groups. This thing right here, it's the result of us doing something. It's the result of us taking x times 3, but then dividing it by 3. So what are we left with when we do that? We're left with how much in each of our 3 groups? Obviously x. So that means that tells us x times 3 divided by 3 gets you right back to where you started. Right at x. Right at x. So let's, don't worry about the solo attempt yet. We'll do that in our transition. Let's go over to where we're looking kind of on page 4. On page 4, I got a few things for you to try out. I want you to see if you can fill in the blanks to these. Fill in the blanks to these. And while you're filling in the blanks, I'm going to put some variable ones over here. We're going to try those after you've worked on these and after we've checked them. So do these. I'll write some variable examples, and by the time I'm done writing the variable examples, we'll be ready to check these. So you don't have to pause, because I'm going to write this while you work on this, just like it were a real classroom. So you're working on A, B, C, D while I write, and then we'll check in just a second. Take about 20 more seconds to see what you think on these over here. And if you're done, you can be writing out our variable problems we're going to try. All right, let's check our answers to A, B, C, and D. So here, if I divide by 3 and then multiply by 3, well, I'm going to end up, this is our identity right here. If I divide by 3, multiply by 3, I'm going to get right back to where I started at, 132. So let's keep going. So here, you had some number, divided it by 25, multiplied it by 25, ended up at 225. So where did you have to have started? Well, remember, this doesn't make it any change, so this must have been exactly where we started. We must have started with 225. Let's try another one. 56 times something divided by 8 gets you right back to 56. Obviously, times 8 divided by 8 doesn't change your number. And down here, 452, we want to end up back at 452. So if I do times 12, I also have to do divided by 12. So times 12 divided by 12 gets me from this number right back to where I started. So there's 3 variable examples. See if you can fill those blanks in. Forgive me, I struggled writing this. I should have used a pencil. This means m times m. Sometimes I'm going to use this x. Sometimes I'm going to use the multiplication dot for a little bit longer. Eventually I'm going to get rid of this. I'm sure you can understand why. But for now, this means x divided by m times m. So try to fill those blanks in super quick. All right, so I'm back here. All right, so I got to divide by m and then times m. If I started with x, I'm going to end up right back x. Remember, these are variables. We don't know what those numbers stand for. All right, f. Let's see. R divided by something times 3. Well, let's think about how we can show this identity. I haven't really given you much information here. But let's say if we divide by 3 and multiply by 3, this isn't going to change our initial or our starting value. So I'm going to end up right back at 3. All right, last one. You had some number, you multiplied by 5 and then divided by 5, ended up right back at z. So where did we have to have started? We probably started at z. And not probably, we definitely started at z. That's what we've shown with this identity.